put together here. But there's a lot of parts to a car. Try putting this back together if you had no directions. No directions. And by the way, you had no tools. And put it back together. And you see there's different materials here. You have rubber, you have plastic, you have sheet metal, you have steel, you have aluminum. And so there's different parts to different materials that make up all these pieces. And if they weren't all in this convenient place, what if they were spread throughout planet Earth? Some of them are going to be at the bottom of the sea, some of them on tops of mountains. And you got to gather all these and put it together. It can be hard. It can be hard. And nobody's going to tell you where these pieces are. Well, that's what you're faced with origin of life. You've got to make the pieces, then you've got to find the pieces and get them there in the same place and time and put them together. The other problem is people say, well, you have the entire universe. Okay, well, we'll spread all those parts throughout the entire universe. Is that better? Going to make you happier? You think you can gather all those up and make that car for me? The other problem is this. The parts go bad. They sit around for a few years and they all rust out. They're no good anymore. You can't use them anymore. It's the same with the origin of life. When you make these chemicals, they don't sit around. They go bad. And so you're faced with all of these problems. So what is the origin of life? Where did a cell come from? A cell is the most basic component of life. Whether you have a cell or a bacterium. How do you get this? How do you get this? This is a factory. This is a machine. It's not just a blob of protoplasm. It is a highly sophisticated structure. And so you have all of these elements in here that where the cell is able to make these carrying rods that carry materials from point A to point B, and then those rods will decompose and form somewhere else as needed. They have these power centers, which are mitochondria. They'll have the nucleus where the genetic information is kept. All of these with their own membrane. Highly complex structure. This is so much more complex than a car. So much more complex. So when you're faced with origin of life, when a scientist tells you we understand where life came from, they are lying, or they just don't know. It's just not true. We have no idea where life came from. This is pre-biology. This is before enzymes. This is before any biology. It's how did you get the raw chemicals put together, and then how did you assemble them into a cell, and now you have life, now you can have biology take over. So, molecules don't care about life. Organisms care about life. Chemistry, on the contrary, is utterly indifferent to life. Without biologically derived entity acting upon them, molecules have never been shown to evolve toward life. Never. They have never gone toward life. It's never happened. All right, so every chemical synthesis experiment in origin of life, so you've got to make all the parts for the car. Well, how do you make them? Well, this is what scientists do in their origin of life experiments. They purchase chemicals from a chemical company in high purity. That's cheating. You have to make these. They purchase them. They mix those and be spread out throughout the earth or throughout the universe. High concentration, and then you get resemblance to one or more of the basic 4 classes of chemicals needed for life. That's carbohydrates, nucleic acids, amino acids, and lipids. So you have these 4 basic classes of chemicals. Just like in the car, you had plastic, you had rubber, you had sheet metal, you had steel. You have these 4 basic classes of materials. Then they publish a paper making bold assertions about origin of life, much like Miller did in the Miller-Urey experiment in 1952, which we haven't gotten any further from that. I mean, it's just about the same as in 1952. Then they engage with the ever-gullible press to dial up the knob of unjustified extrapolations. You watch the mesmerized layperson exclaim, "You see, scientists understand how life was formed." And then you encourage a generation of science textbook writers to make colorful, deceptive cartoons of raw chemicals assembling into a cell and then emerging as slithering creatures from a prehistoric pond. This is fallacious. It's not real, but this is what's in books. You ask any real scientist, do you know any of these parts? Do you know how raw chemicals came together to make a cell? No, we don't. We have absolutely no idea. Do you know how cells got together and made these living creatures that can come crawling out? Absolutely, we don't. So all of this is fictitious, and this is what we teach people in school. Here's the synthesis problem. Molecules that compose the living systems always show homochirality, meaning that you have to have a left-handed molecule and a right-handed molecule, and the non-superimposable mirror images. You only get one particular mirror image and not the other. It's very hard to make just one and not the other. Very hard. And every experiment in abiogenesis has made the racemic mixtures. Those don't work. So even what you tried to make doesn't work. When building molecular systems, constant redesigns are needed, taking you back to step 1. So if you do something wrong along with synthesis, you can't go back to the beginning. You have to go back to the beginning. You can't fix that thing now. The synthetic reactions don't know how to stop. So say it's going along and all of a sudden it's made a carbohydrate. So you can begin to make a carbohydrate, which is the backbone upon which DNA and nucleic acids are strong. It doesn't know to stop there at the carbohydrate. It'll put another group on there too. And now it can't be used anymore. And you say, well, you went too far because it doesn't know where to stop. It has no target. Imagine trying to make a car and somebody's told you, we're not going to tell you what you have to make. We have it on our mind, but we're not going to tell you. I don't know if you want a car or a house. I'm not going to tell you. You got to figure it out. And you got to make the parts. And you got to put them all together. With no directions. You're crazy. That's exactly what we're faced with in origin of life. Time, although often claimed, oh, billions of years thought these things had happened. No, because if a chemical is made, it's going to go bad. Remember those parts turn rusty? They're not good anymore after a few months exposed to the atmosphere. You say, well, early Earth was different. Yeah, early Earth was harsher. It had more ammonia. It was much harsher, less oxygen, more ammonia. All right, a prebiotic system doesn't have the ability to easily purify structures. You have to be able to purify things for them to go along. And then there's this reagent order is essential. So say you're making a cake. You're making a cake and you say, well, I've got this frosting here. I think I'll mix it with the flour and the eggs. It doesn't work. Well, what's wrong with that? Well, the problem is that you have to put the frosting on last. All of chemistry is like this. You have to put things in an order. There's a precise order for putting things together. How does an abiological world know how to do that? Nobody knows. Every parameter for temperature, pressure, solvent, characterization is really important. How do you characterize after each step? The way biology characterizes is you have an enzyme will come down and grab a substrate and say it fits. If it doesn't fit, other enzymes come and break it up. That's biology, but we are before biology. Nobody knows, no scientist knows where life came from. Isn't that amazing? Everybody thinks scientists understand. They don't. They're clueless on this. There's a mass transfer problem. So you start with a kilogram of material, and you take it along a number of steps, and you end up with 2 milligrams of material after 10 steps. So what do? You go back and you make more starting material, but now you've written down how you made it, so now you can end up with much more at the end because you don't have to try all those other things you tried going along. But nature never keeps a laboratory notebook. So say it's going along for 500 million years, and it makes something. Now it runs out of starting material. Well, how do you make it again? I don't know. I didn't keep a laboratory notebook. Well, shame on you, nature. You never kept a laboratory notebook. You're never going to get to life. All right, so this is one of the steps just to make a part, the rotor part of the car that was spinning along. So you see that we're cooling here. There are all these different steps. If I just describe to you this one set of steps, this is the procedure for it. So this is what a chemist would understand. To an oven-dried 3-neck round bottom flask charged with hydrazone 33, this many grams, this many millimoles, magnesium sulfate was added, dichloromethane. To the suspension, which quickly added manganese dioxide at 5 degrees, and you cool it to minus 15 or minus 10 for an hour and a half. Then you cool it to minus 50, and you cool it in. You're warming it, you're cooling, and if you go back, you see all these steps. You're cooling, you're warming, you're cooling, you're warming. How does nature do this? Nobody knows. People will say, oh, well, this was on the edge of a volcano. That's how it heated. Okay. And the next step, where were you then? Well, let's say we were on the edge of a glacier. Oh, that's cool. And how did it get over there? I don't know, just kind of, and then how did it warm up again? All of these problems, nobody knows how these things happen. Then the other thing is characterization. How do you know the structure of the molecules? The pharmaceuticals that you take, how do we know the structure of those compounds? Well, you do something called nuclear magnetic resonance, and it gives you a bunch of peaks, and from these peaks you can figure out the molecular structure. So you see these peaks, and then we have to convince our colleagues that we understand the structure. So we publish papers and we write stuff like this, which is a bunch of just numbers and words that don't make sense to any real person. And this is what we have to do to convince our colleagues that we've made what we made. But that's just the first part. There's a second part. So you have a whole other page of this just to describe that one molecule. How does nature do this before a brain? Nobody knows. Nobody knows. No scientist knows. So if they tell you they know, they're rookies. They don't know what they're talking about. No real scientist will tell you that they understand this. So when we published this paper on the nano cars, we had 280 281 supplemental pages, like the 2 pages that I just showed you. 281 of those just describing how we know the structure is what it is. And so you have to know the structure in order to go on to the next step, or you're just going blind. The other thing is, if you put a part in, you can't change it. So this was the first nano car we made. It had this little rotor here, and we would shine light on it, and it would spin, but it only would spin at 1.8 revolutions per hour. Not very fast. But when we pull this sulfur out and go to a 5-member ring here, then it would spin at 3 million rotations per second. That's screaming fast. Little change makes a big difference. Well, how did we get that sulfur out? Well, you just erase it and you put that. No, you can't do that with real chemistry. You have to go back to step 1. So when nature is going ahead and building something, if it does something wrong, it's stuck forever. It has to go all the way back to step 1, but it's been working on something for 2 billion years. Too bad. You gotta go back. Nobody knows how origin of life came about. Now, say you had all the parts. We can't make the parts. Just showed you. But say we had all the parts. We had the carbohydrates, the lipids, the nucleic acids, and the proteins. How are we going to assemble them? Well, people have taken lipids, which are just fats, and they put this in shear and water. Maybe you've shaken together oil and water, and you've seen these little droplets. That's something like this. And they'll take these acetolipids and they'll shake this up with water, and they'll get this. They say, wow, that looks like a cell. I got a protocell. A protocell. And then they'll publish a paper, and the media will grab this up, and the layperson will be misled. Well, what's a real cell membrane look like? Well, it's not just homogeneous lipids. There are 40,000 different lipids have been identified as part of these cell membranes. And the outer surface is different than the inner surface. Nobody knows how that's done. We can't even do that in a laboratory. We have no idea how it's done. And then you have all these other organelles. So you have the outer side different than the inner side, and then all the organelles inside, the mitochondria, the nucleus, they all have their own lipid membranes, and that's a different constitution with different lipids. We don't know how to do that. Nobody's ever done that. We have proteins that go through here that are these gatekeepers that allow certain molecules in and other molecules out. We have ionophores that allow certain molecules in and certain molecules out. The pH balance, the ionic balance between the outside and the inside of the cell is extremely important or the cell explodes. Every cell has this ability to regulate itself. It's utterly amazing. If you look at just what's on the surface of these cells, these are these glycans. You've heard that DNA can store a lot of the information. DNA is nothing compared to glycans. These sugars can store an enormous amount of information. That's how cells recognize each other on the surface. If you have 6 bases on DNA, 6 of the same bases, A, 6 bases, there's only one way that you can put that together, a string of 6 in a row. If you have 6 of the molecules, D-pyranose, this is just a sugar. This can hook together in over 1 trillion different ways. Nobody knows. If you get the wrong structure, it doesn't work anymore. The cell won't work. Nobody knows how this has been done. 1 trillion is a huge number. Most people don't know the difference between a million, a billion, and a trillion. Let me help you. All right? A million seconds is 11 days. A million seconds is 11 days. Somebody tells you, somebody says, you go up to somebody, I'd like to marry you, they say, I'd tell you in a million seconds. Okay, 11 days, you'll let me know. If they said a billion seconds, that'd be 32 years. If you feel the difference between a million and a billion? Now, if they said a trillion seconds, that'd be 32,000 years. This has got over 1 trillion different ways you can hook it up. You hook it up wrong, it doesn't work. How does this happen on an abiological Earth? Nobody knows. How does it happen with biology now? Enzymes are around which nature's little nanomachines which build and construct these things, which deal with us, which construct our bodies, which take the food that you ate this morning, the scrambled eggs you ate this morning, and it's a part of your nose by this afternoon. This is how it breaks these molecules down and builds it up. Nature's doing this. Biology is amazing. The interactors. This is just the molecule-molecule interactions in a single yeast cell, which is a simple cell. The molecules have to be arranged properly for information to transfer through them. This is through something called virtual photons. The number of ways that you could have these aligned with each other is 10 to the 79 10 to the 79 billion. Well, what's 10 to the 79 billion? That's a 1 with 79 billion zeros after it. Just to show you how big a number that is, the number of elemental particles in the universe, not just in the universe, is 10 to the 90. This is a 1 with 90 zeros after it. This is a 1 with 79 billion zeros after it. Is the number of combinations that you can have. It's extraordinary. Nobody knows how this is done. So, proto-turkeys. Origin of life protocell assembly is akin to buying 20 pounds of sliced turkey meat, adding a gallon of turkey broth, warming, sticking with a few feathers, and suggesting a live turkey will eventually come gobbling out if given enough time. Or then a proto-turkey or extant turkey had been synthesized. We know this is a bunch of nonsense. And this is exactly what their experiments are doing. And so some of us are calling them out on it now. And there's no defense. Origin of information. So this was just making the 4 classes of compounds and then assembling them. There's another problem. What's the origin of the information? You have to have the code. What if you have a computer and you have no software? You need the software to run it. You have to have the code to run it. Well, DNA and RNA are the code. But there's nobody knows where the code came from. You can't just have nucleic acids. You have to have them hooked in a certain arrangement to be the code for those DNA to transfer to RNA, to transfer to proteins to build our structures. Nobody knows how this was done. The code is missing. It's like having a box of alphabetic letters versus having a big book. The book has all the stored information. The letters don't give you any information. We just have the letters. Where'd the code come from? Nobody knows. Clueless. Try to build a cell. So you can get the dream, you can get all the smartest people you want together and say, we'll give you all the chemicals. Can you build a cell? No, it's impossible. Okay, we'll even take the chemicals and we'll hook the DNA in the order that we want. So you tell us whatever code you want, we'll hook it together in that order. We'll give you all the amino acids hooked together as proteins to even give you the enzyme structures. We'll even give you the enzymes. Could you assemble a cell? The answer is no. Nobody can do it. Craig Venter had claimed to make a synthetic cell, but what he did is it's like you buy 2 Corvettes. I buy 2 Corvettes, and what I do is I take the control box, computer control chip, out of one of the Corvettes, and I put it into the other Corvette, and I say, hey, I made that Corvette. You'd be like, come on, you didn't make the Corvette, you just took the one piece out of it. That's exactly what Craig Venter did. And he claimed a synthetic cell. That's what he did. The origin of life can't be that way. So this is what the kind of things that are written for our children in school. Life began with little bags of garbage, random assortments of molecules doing some crude kind of metabolism. That's stage 1. That garbage bags grow and occasionally split into 2, and the ones that grow and split the fastest win. Huh? Few origin of life researchers would have stated it so shamelessly. Nonetheless, the little bags of garbage are precisely what they've been making. Those little bags of garbage have no more resemblance to living cells than a big bag of garbage has to resembling a horse. This is a bunch of nonsense, and this is what we fill our high schools with. Well, it's no better in the academy. It's no better in the universities. Here's an article that came out, written in Science magazine, which is the top journal in the world. It says, biologists have created the most lifelike artificial cells. This just came out less than a year ago. So I looked it up. I wanted to see, what are the most lifelike artificial cells that they've made? And this was citing a paper from Nature Communications. And here's what happens. They take semi-porous microcapsules made of plastic. They took plastic and they put clay inside. And clay is positively charged. DNA is negatively charged. So they add the DNA to the water. They add this plastic beads to the water, and the DNA ends up going through this semi-porous plastic, and it sticks to the clay. Positive and negative charges come together. And then they buy ribosomes, which are enzymes, RNA, and other enzymes, reagents, all purchased or extracted from living systems. They put that in the water, that goes in, and protein synthesis occurs. Well, you add those molecules together, protein synthesis is going to occur. That's not life, that's just chemistry. So life was occurring, and they call this quorum sensing because the nearer ones get to it. So the chemistry of exogenous reagents will work regardless of the container, whether you do it in a semi-porous microcapsule, you do it in a test tube, or you do it in a large industrial vat. A lot of the things that we consume are made exactly that way. A lot of the foodstuffs are made exactly that way. But they did it in a microcapsule, and they said, oh, that's life right there. That's not life. It's just chemistry making molecules. You bought everything and put it in there. There's no rivalry here. One might arguably agree that these are indeed the most lifelike artificial cells, but that only serves to underscore the point. Nobody has ever come close to generating the workings of life. Not even close. So, fool's gold. Alchemists used to try to make iron, convert iron into gold. And so what they found is you could add sulfur to the iron, and it eventually will look like gold. But they knew it wasn't gold. It didn't have the same melting point. It didn't have the same ductility. But they thought at least we're getting close. No, they weren't getting close. You can add sulfur all day to iron or to any other element. It's not going to turn into gold. The only way you can turn iron into gold is you have to add a bunch of protons to it. And that takes a nuclear process, which is very expensive. So, I'm calling the community for a timeout and just saying you guys aren't close. You don't have to, you got to figure out where life's code came from. You have no idea how to deal with the interactomes. You have no idea for the mass throughput. None of this is there. And so, just calling for a timeout. Then we'll get to evolution. So that was abiogenesis. That was before life. A lot of what we hear about is life itself. What about evolution? How does evolution occur? Well, evolution is both about the mechanism by which change occurs over time and the theory of universal common descent. This is what my geneticist colleagues have told me evolution is about. I said, well, evolution, if you learn that evolution is like what Darwin said, where random mutation and natural selection account for the diversity of life, scientists themselves no longer believe that. So what you were taught as fact is no longer fact. It's changed. Oh. Look at that. Facts change. Yeah, because they were never facts to begin with. They were theories. Evolution is both about the mechanism by which change occurs over time and the theory of universal common descent. So the theory of universal common descent has a remarkable amount of data going for it. But there are some problems there. Let's look at some of the problems. Humans have about 20,000 protein coding genes. What does that mean? So that in your DNA, there are segments in the DNA that code for proteins, that are the template for proteins to be built via RNA. Once the protein is built, that then constructs our bodies. That's what does the construction. It's really amazing. These little nanomachines build us. There are 20,000 protein coding genes, but those protein coding genes are on only 1.5% of the DNA in our genome. The other 98.5% was formerly called junk DNA. Well, now we're learning that that's not junk DNA, because in 2003, the U.S. National Genome Research Institute, which is part of a governmental institute called the Encyclopedia of DNA Elements, or Project ENCODE, wanted to say, what's going on with the other 98.5% of the DNA that was formerly called junk? Well, what they're finding is that there's much evidence that these intergenic regions, which are no longer called junk but intergenic regions, have regulatory elements that can affect gene transcription, the building of us. So, when people say we are 99.9% the same as a chimpanzee, that is correct when you look at 1.5% of the DNA. When you look at the other 98.5% of the DNA, we're different. We're different. This is huge. You've just narrowed your selection over a very small amount of space. And we're finding every year more and more things that are coming from the other 98.5% of the DNA that was formerly called junk DNA. Common descent versus uncommon. There's work on orphan genes, which are called orphans, cast new light on uniqueness of some genetic information. These are unique to narrow taxon, usually just to a certain species. These are unique. These are markers for uncommonness. Okay, let's look at the uncommon human being. Human beings alone have the capacity for art, music, advanced communication, advanced mathematics, and religious practice, which constitute the broader organization of symbolism. Therefore, if one is intent upon a common descent model, There was a massive and presently unexplainable infusion, intrinsic or extrinsic, along the proposed very short descent pathway between Australopithecines and the modern humans. So what does this mean? So scientists don't claim that we were descended from chimpanzees. They claim we had a common descendant. So there's this common descendant, and that chimpanzees went here, humans went here. But humans didn't come directly. There were certain lines which the humans are coming down. So we went through Australopithecines and Neanderthals, and right after that come humans. So that's what they will say. But something happened between Australopithecine and human, between their brains and our brains, which made us be able to relate through all of this symbolism. Because Neanderthals didn't have advanced mathematics, didn't have advanced communication. I can tell any one of you, you go out the front door and you go 10 feet north, due north 10 feet, dig a hole 7 feet deep, and you will find a little box. And in that box, you will find papers and an instruction. Try to explain that to a monkey. You could never do that. We have advanced communication that goes very deep. Nobody knows what happened between that brain and this brain, Australopithecine and human brain, because we can't detect any differences in the structure, in the chemistry that would account for this. The chemical basis of the evolutionary mechanism for such change is both unknown and presently immeasurable. Remember what evolution is about? Universal common descent, which we just showed is showing a lot of uncommonness, and mechanism. Nobody knows the mechanism. Mechanism means showing the chemical transformation that occurred to have that difference. Nobody knows. So on both counts, you're clueless. You're clueless on this universal common descent. There's a lot of uncommonness. And the other count, the mechanism just isn't there. If the infusion were extrinsic, meaning coming from the outside, then the materialist evolutionist and the supernaturalist share common ground. The mechanism problem is seen here. Body-plan disposition. So, for example, a human body, our limbs are disposed differently than the limbs, say, of a tiger. Tiger's limbs are disposed differently. This is change in body plans that are different. Nobody knows how there has been change in body plans in an evolutionary model. The mechanisms are unknown. Nobody knows the chemical mechanisms. So any massive functional change of a body part has to have a change in mechanisms. The problem is the requisite mechanisms of biology are absolutely unknown. So biology has been evolutionary biology has been reduced to storytelling. It's been reduced to storytelling. So I asked my biologists, how does that happen? Oh, they say one small change at a time, this changed. What changed? Show me the chemistry, what changed? And then I present them with the other thing that tells a totally different story. It's been reduced to storytelling. There's no mechanism. So I'll say, show me the mechanism of a complex system change. And they will often say, well, the immune system changes. Right? The immune system morphs depending on what's presented to it. But the immune system remains an immune system. It never becomes a digestive system, never becomes an auditory system, never becomes an optical system. It remains the system that it is. Show me the change. And they'll say, oh, the references are there. I say, okay, find them. And they never come back. So I tell you, no answer is an answer in itself. Then when I push them, they say, you can look it up yourself. I say, I haven't been able to find it. And so then they give me a Google dump of a bunch of different URLs. And I sit all Saturday in my office going through each one of those papers. It's not there. Was this a trick? It wasn't there. And I have people come in, oh no, the mechanisms are known. So if you're a biologist and you say the mechanisms are known for changing a complex system, I urge you, look it up, find it, and then come to me. Don't proclaim you have it until you try to find it. It's not there. All right, so there's collective cluelessness. Therefore, I don't understand the mechanisms needed to change body plans or the mechanisms along the descent pathway from Australopithecine brain to modern human brain, if we were indeed commonly descended as predicted by the theory of universal common descent. And nobody else understands the mechanism either. Nobody. But unlike most, I'm saying it publicly. Now, I'm not speaking about a God of a gap. So now I'm done with the technical part. I'm not saying that because we don't know something, therefore we will never know. We can't know that. As a scientist, I have to be really careful about my words. There are many things that we do not know today that we will know at some point. We just don't know it today. If you think about the structure of DNA in the year 1900, nobody knew how our information was stored. Then in the 1950s, it was discovered how the information was stored. So many things we'll find, but I can tell you that as of today, we are clueless on the origin of life, and we are